Hey everybody, in this section we're going to look at polynomials and we have several learning objectives. We're going to identify the degree and leading coefficient, add and subtract, multiply polynomials. We're going to use FOIL and operations with several variables. There's some nomenclature here that I think you're familiar with, but we will review leading coefficient, leading term. We'll talk about the degree of the polynomial, how we want to write our polynomials in descending order. And here's a more fleshed out definition for you. And here's some more bolded key terms. Coefficient is the number in front of the variable. A constant is a number without a variable. We have terms, degrees. I'm going to jump into it here with example 1. We're going to identify the degree, the leading coefficient, and we're going to write the leading term. So first I'm going to write this in descending order where our powers are going from highest to lowest, and our constant term, 3, we could say has an exponent of x to the 0, and we know what happens when we raise a variable to the 0th power. So our degree here is degree 3. It's the highest power of this polynomial. And the leading term is the first term that we write with the highest degree. So in this case, it's negative 4x cubed. That's the whole term. There are 3 terms in this polynomial, and that one is the leading term. And the leading coefficient is the number in front of the variable, which is negative 4. That is our leading coefficient. Okay, our next one's already in descending order, so I don't have to rewrite it. So my degree here is going to be 5, because that's the exponent on the leading term. The leading term is going to be 5t to the 5th. And the leading coefficient is also 5. Okay, so for C, we do have to rewrite this if we want to write it in descending order. So we're going to say negative p cubed plus 6p minus 2. I recommend you do this because it helps identify more easily the parts that we're looking for. It's a degree 3. The leading term is negative p cubed. And it is, even though we don't see a number in front, we know there's a 1 there, so it's negative 1 is our leading coefficient. Okay, very good. These are done. Example 2, adding polynomials. Find the sum. Okay, so we have these two polynomials that we're adding. Why don't we write without parentheses here? So we can just, there's nothing to distribute here. It doesn't change any of our values. And from here, we can look at grouping them into like terms so that we can add those like terms and then simplify. So let's do that. I'm going to reorder this in descending order. So my 4x cubed is first, and then I have some 2x squared terms here I'm going to write. And then I'm going to see if I have any just x terms. I've got 2 to put those down next. And then my constants. I have 2 constants in this problem. It's negative 21 and 20. And now we can add the like terms together. Some people can do these 2 steps together. I'm going to separate them so I'm absolutely explicit on how we simplify when we're finding the sum of these 2 polynomials. 12x squared plus 8x squared is 20x squared. 9x minus 5x is 4x, and then we have minus 1, negative 21 plus 20. Box that in. That one's done. Okay. How about let's find the difference? So the difference means subtracting. And so we're going to remove the parentheses here, but we have to distribute this negative through this polynomial. And then we're going to follow the same steps as we did before. We will group like terms and then add like terms and then simplify everything. So here I'm distributing this negative. Remember, a negative times a negative is a positive. Okay. Now let's write this in descending order, grouping all of our like terms together. 7x to the fourth. Okay, that's the highest power, so that would be my leading term. I only have one x cubed term, so I'll put that next. I've got two x squared terms. I've got two x terms. And I have two constants, the 1 and the -2. Okay, let's add like terms. Box it in, and we're done. Okay, hope that makes sense. I know you guys have seen this before. Just knock some rust off. Okay, let's multiply. So multiplying polynomials using the distributive property. So I have a binomial times this trinomial. We can distribute each term in the binomial to each term in the trinomial. So let's write 2x times, and now that's going to distribute into this whole trinomial 3x squared minus x plus 4. And then the 1 times 3x squared minus x plus 4. Color coded it, maybe you can see it a little better. So here we're distributing the 2x first. 2x times 3x squared. Remember our rules for multiplying exponents. We have the same base x, and we're going to add 1 plus 2 is 3. Okay, did that. Now I'm doing the second part. I'm distributing the 1 into this trinomial. That's all set. Now let's group our like terms together. I've got two x squared terms. I've got two x terms, and I only have one constant. That's 4. Okay, now we can add them up. 6x cubed plus x squared plus 7x plus 4. Box it in and we're done. And that was example 4. That's right. I wanted to show you guys an alternative method here. So we could do a table with this trinomial multiplying this binomial. And I'm setting it up like this. The 2x and the 1 are in the column, and along the rows 3x squared minus x times 4. And we're going to multiply the row in the column. And I've got it set in purple here. So 2x times 3x squared is 6x cubed, etc. And then just write all the values inside the cells that we multiplied and get them, group them together with like terms, which I already have here, and add like terms. And you're going to see here we get the same solution that we did when we distributed. This is, some of you learned this way, and maybe this is an easier way to organize your work. It's your choice on which method you want to use. I wanted to show it to you there just as an add-on. Okay, FOIL. First, outer, inner, last. You guys have seen this for sure. We're just doing a binomial times a binomial, and basically we're still just distributing the 2x here into the two terms of the binomial. That's the first and the outer. So 2x times 3x is 6x squared. Now we're distributing to the 3. That's our outer term. So we've done all the 2x, and now it's time to distribute the 18 into this second binomial here. So we go inner, negative 54x, and then outer, negative 54. Let's do a different color here. Orange for the last. And then we can add the middle terms together. Uh, 6x squared minus 48x. Come on now. Sometimes my stylus doesn't cooperate. Okay. Am I going to box that in? There we go. Foil. You know, you can also use that table method that we just did before. Okay, I want to show you a perfect square trinomial. So if we take a binomial and square it, we get a pattern that we can see every time we do this when we have a binomial squared. It's going to be the first term is going to be the x part squared, the last term is the a part squared, and the middle term is always 2a times x. If we are not sure about this pattern, or we just don't remember the equation, or we just want to fall back on what we know, we could use FOIL, right? So just do first, outer, inner, last. So 3x times 3x is 9x squared. 3x times negative 8 is negative 24x. And then when we do the second part, notice we get the same middle term. We have two of those. So that's why we see the 2a in the formula there, because there's two of the exact same terms. So here it is boxed in. I did the FOIL. But if we want to use the formula that we have right here, let's identify the parts here. So the x part would be is 3x. And the a part here is negative 8. So we're just going to do the x part squared, so that's going to be 3x, square that whole thing, parentheses, plus 2 times negative 8 times 3x, plus, and we can do the whole negative 8 squared. Okay, so 9x squared is our first term. We do all this multiplication here, we get negative 48x, and then negative 8 squared is a positive 64. Look, we got the same thing. It's a different way of doing it. It's a pattern-based thing. So once you recognize the pattern, this does become easier in the long run, because it's just less work for us to have to do the FOIL. Okay, so let's move on to, I think we're doing the difference of two perfect squares next. Yep. And here we got a conjugate pair. So we have an a plus b times an a minus b. And we saw this when we worked with our imaginary numbers, right? Our complex numbers, when we were trying to get rid of I. This was a method that we used to get rid of the middle terms. So if I do 9x plus 4 times 9x minus 4, I guess let's identify the a and the b part here. So a is going to be 9x and the b is 4. So I can say positive 4, but it'll be minus in the equation. So this would be 9x quantity squared minus 4 squared. I'm using the formula part here. So this gives us 81x squared minus 16. Okay, so if I want to FOIL this, I could, and I'll get the same answer. But again, once we understand the patterns here, math is all about patterns, then we not only fully grasp the concepts here that will apply later and make math easier for us later. It'll make math easier for us now, because it's just less work for us to have to do. Notice the middle terms here cancel when we FOIL. Net negative 36x and the 36x. Cool. All right, we got one more left in this example, and it's pretty much the same that we just did in a previous example, except we have two variables here. We have an x and a y. And, you know, we're just going to treat this just as a normal distributive kind of thing here, where we're going to take x times the trinomial 3x minus 2y plus 5, and then we're going to add the 4 and then distribute that into the 3x minus 2y plus 5. And we'll distribute, we'll group, and we'll add like terms and simplify. We could also make a table like we did before with the row and columns. If you like that method, that's perfectly suitable and appropriate. I'm going to do this one for now. I'm just distributing everything. 4 times 3x is 12x. 4 times negative 2y is negative 8y. And then I got 4 times 5 is 20. That's my only constant there, that 20. Now let's see, what like terms do we have? 3x squared is my leading term. It's a degree 2. Let's put our xy's next. There's only one, so there's nothing else to put together. Notice we have all these are different like terms. Our x's are like terms, the y's by itself, the xy's by itself, and that one's done. Okay, very good, everybody. Hope that makes sense, and let's hit that practice set soon.